All right, very good evening, everybody. So today we're gonna continue talking about the main types. Uh, so we are not at the most basic level, but we are just one level above the basic, and we're gonna keep building up on that. So what we have talked about before is just the main types. Okay, so we talked about all these. Now we're gonna talk about the set types and the mapping types. Okay, well, actually, there is a category called mapping types, but there's only one type underneath, so which is a dictionary. All right. So before we talk about maps, sets, and dictionaries, we need to understand the concept of a hash function or a hash. Okay, so what is a hash function? It's just it's kind of algorithm that takes any value of any size and turns it into something of fixed size. Okay, so it's a function. There are several algorithms that are able to do that, and that takes anything of any type and turns it into something that is very consistent and of fixed size. Okay. Now the implementation are very sophisticated and they are supposed to be unique. They are not supposed to collide. Like we have numbers, we want to deal with these as if they were numbers. Okay, so here's the thing. Let's look at this table. Okay, before the hash. So usually we have a list of values that has an index, so we can access the particular entry using the index, right? So what is the time complexity if I want to access one of these elements using the index, the numeric index? Okay, I saw you first, yes. O of n, like using the index. So if I know I want element at 87301 constant, okay? But if I want to find the element based on a name, let's say I want to find John Smith. So what's the complexity of that? Yes. Yes. Not using the index, using the name. Yeah, because O of n, because we're gonna have to look into every single element and see whether it's equal to the value. All right. If we know the index, we go directly to where it is. So that's a constant, O1. If we don't know the index, we don't know where it is, we have to search all the elements in the list, which is On. Right? Yes, question? Him.
If we have the name, we just hash it and find it where that is.
Yeah, we didn't talk about the hashing yet.
Oh, okay.
Before the hashing. Okay. So we just have the name and the index. So either if we know the index, that is the location of the element in the list, we go there right away. If we don't have a hash, we just have a name and we want to find it, then we have to look for it in every element in the list, and that's On, right? Okay. But oftentimes there are some values that we want to search for that is not the index. Okay, and we want to increase the enhance the performance. So we create a hash for that value. So let's say, for example, if it is common that we search by phone, so we need to create a hash for the phone. If it's common that we search by name, then we need to create a hash to search by name. Okay, so that's the indexing of the values that are not numeric. Okay. Now the numeric values are easy because it's just a number that you just added to the original address, and then that's just a constant operation, right? Now if you have a value that you don't know what the length of it is, and it's just it's more complicated. Now when you turn it into a hash, something really consistent, we can treat it the same way we treat the number. Okay, so if we turn the name into a hash sum, or sometimes we call it hash code or hash value, or just simply hash. Okay, then we can use that name as index, because internally it will be turned, we use the same function, turn it into a hash and just search for that exact value, and you find that exact value in the list. So we turn an O of n search into an O of 1 search. Okay. There's something, maybe when we get to talk about dictionary, I will let you know about that. Okay. So that's a general function called the hash. Okay. And in Python, there is a function called hash that implements the algorithm. We don't need to talk about the details of the algorithm now. It just takes any value, as long as it is a hashable value, and turn it into a hash code. So what is a hash value? Now, because when you convert something into a hash, it has to be a unique thing. So you have to be able to compare them to each other. So the values need to have some sort of a consistent identity in order to be able to compare them and create the hash for them. Okay? If you have an object that can change, its identity will change. Okay? But if you have objects that cannot change, that is the immutable object, then that immutable object have an identity that doesn't change. Okay, so you use this identity as the comparable value. How to compare two objects? You compare them by this consistent identity. Okay. So bottom line, not every object in Python can be hashed. Okay. If an object can be hashed, we call it hashable, and that's with the type of object that we can send to the hash function and receive the hash code. So in order for it to be hashable, like a subset of the hashable objects are the immutable objects. Okay, so for our context here, we can use them interchangeably. So in order to use a hash, we need to use an immutable object. Yes.
The previous slide wasn't an example because you had different strings where you think you hash values that have the same thing. Wasn't just
In the previous slide?
For example, does this actually what it means? How would you have a longer string that it produces a hash value of the same name?
How? Like there are several ways to do that. There are several algorithms to do that. A simple way, like for example, I don't want to get into the details of a hash algorithm, but you can put it into like take the Unicode values of the string, for example, and do some calculation on it to get the result.
Yeah, so would you longer string
No, it's still length, yeah. It will still reduce its index. You can look into a hashing algorithms, but the end result is a consistent length. The hash sum is always consistent in size. Okay. Even if we have longer lists, it would be similar to the output here. So we can try it out even. But the point here, if I try to send a list to be hashed, it will give me an error. Why? Because the list is unhashable. It's mutable, so it's unhashable. But if I try to send a tuple, it will create the hash sum for it, because the tuple is immutable, so it can be hashed. So let's try it out and see how does it look like. Okay, so if I create hash of a string, so let's say ABC. Okay. Now, if I try to create hash for A, B, C, D, E, F, G, H, I, J, K. okay? If I try to create a hash for a tuple, so that's a completely different type of object altogether. So let's say, all right. Now let me try to a longer or a shorter tuple just for you to rest assured. So always the hash number is also always a consistent value. Now, what if I try to hash a list? It gives me an error because the list is unhashable, all right? Because it is mutable. Now, whenever I have a list that I want to hash, then I need to turn it into tuple first, okay? Now, why would we want to hash a list? That would be a good question. That's when we need to put it in a set, or we need to put it in a dictionary as a key of a dictionary, then it must be hashable. Okay? So we see the sequence, so immutable is hashable, and then therefore it can be stored in a set or in a dictionary.